Hello and welcome to another video of Matuklasan. So in this video, we're going to talk about the basic counting principle, specifically the multiplication rule. So suppose you are ordering a latte in Cafe Muna. Then you have your choice of the sizes like small, medium, or large. And you can include one of the following flavors in your order. You have mocha, vanilla, or cinnamon. Now, the question is, how many different choices of latte can you have? So, for us to do this, we can actually list all the possible ways or combinations by using what we call tree diagram. So, first event is to choose the size of our drink. So, for that, we have small, medium, and then we have large. So this is called tree diagram because we are like branching out the different events that we could choose or the possible options that we could choose per event. So in this example, after choosing the size, we're going to need to choose the flavor for our drink. So here we have the choices for the mocha, we have the vanilla and cinnamon. And of course, one way is to choose the medium size drink and choose among the three flavors, mocha, vanilla, and cinnamon. Same with this example. So we have M, B, and C. So our first come away or combination is small, and then the flavor is mocha. The second is small, then we have vanilla. Then we have here small, and then cinnamon. Okay. So there are different ways, and by counting all these possible lists, we have how many? We have three for this. Okay, we also have three ways here, then another three here. That is for a total of 9 ways. So we have shown all the possible ways by using a tree diagram. Now let's have this example. So we have three members of a social organization and they have volunteered to serve as officers for the following year. Now, the positions that they can choose from is the position, of course, for the president, followed by the position for treasurer, and then for the secretary. Okay, so remember that we don't have the names of those persons, so let's just name them person A, person B, and person C. So the first event is person A will be the president. Okay, so if person A will become the president, either B or C can be the next treasurer. So what if B became the treasurer? So of course, C here will become the secretary. So another event is that C will become the treasurer and then B will become the secretary. And by doing this pattern, we will also have here A and C, then C and A. Oh, I guess I need to choose capital letter for this one. Yeah, okay. So about here, we have the choice for A and B, and then B and A. So listing all these possible ways, we have person A becoming the president, B becoming the treasurer, and C becoming secretary. Then we have A, C, B for this. Then we have here B, A, C, okay, and we have here B, C, A. Last two, we have C, A, B, and then CBA. So all in all, we have 1, 2, 3, 4, 5, 6 ways. But have you noticed this kind of technique, though it's effective, it's a little tedious on our part because we have to list all the possible ways and events. But what if there are several options? So what if there are 40 kinds of choices? And this is where the fundamental counting principle comes in. We call it the multiplication rule. Okay, so for example, in a sequence of n events in which the first one has case of 1 possibilities and the second say has case of 2 and the third has case of 3. So we can find the total number of possibilities by following this sequence. So all you have to do, guys, is to determine, for example, the number of possibilities for event 1, for event 2, etc. And all you have to do then is to multiply all these possibilities. So if we have 3 events, identify the number of possibilities for each event and then multiply it to get the number of ways that you can arrange or combine all the possible options or choices. Let's have an example. So here, there are 4 basic blood types represented by letters A, B, and O. Now, in genetics, of course, we also have what we call the Rh factor, right? We actually have type A, and we can classify them as A plus or A minus. Okay, if you're B, then you can be classified as B plus or B minus. Okay, now if a local blood bank labels donations according to the type, Rh factor, and look at here, the gender of the donor, say male and female. Now, how many different ways can a blood sample be labeled? So it's easier for me to solve these kinds of problems by creating blanks or lines. So for example, for the first event is for us to choose the type of blood. So here we have 4 possible blood types. So I'll write BT here for blood types. And then the second event is we need to choose the Rh factor. So let's just write here RH. Okay, and then the third event is choosing the gender. Okay, for this one. All right, so according to the multiplication rule, we need to determine the number of ways or options that we have for each event. So how many blood types do we have? Here we have 1, 2, 3, and 4. So I'll just write 4 here. Next is to determine the number of Rh factor that we have. So we have just 2, positive and negative, or plus and minus. So that's 2. I'm gonna write 2 here. And for the gender, say we only have have 2 gender for this classification. We have male and female, so that's 2. Okay. Now all you have to do is to multiply these 3 numbers. So 4 times 2 times 2, the answer is what? The answer is 16. So there are 16 ways to identify each combination or arrangement in this kind of setup or example. Now remember, we can also do this in our previous example. So I don't know if you remember it or if you still remember it, but for the choices for the latte in Cafe Muna, we have the choice for the size and then the choice for the flavor, right? So how many sizes do we have there? We have 3. How many flavors do we need to choose from? We also have 3. So multiplying this will give us 9. So that is 9 ways. Okay, and in the previous example about the positions in the social organization, we have the position for the president, for the treasurer, and secretary. So if the president will become if person A will become the president, B or C, okay, there are 3 ways to do that, right? Either person A will become the president, or B or C. Okay. Now for the treasurer, you only have 2. Why? Because if say person A will become the president, he's no longer the choice for the treasurer, correct? So for the treasurer after choosing the president, we only have 2. And then for this one, after say A becomes the president and B becomes the treasurer, of course we only have one option for the secretary. So the solution here is not 3 times 3 times 3, but rather 3 times 2 times 1, which is 6. So as you can see, we really need to identify if the number of events or the choices that we will have per event is just the same. Okay. Actually, if you started with the correct secretary, it's fine actually. So for example, you start with the secretary, you have 3 choices there, and then for the treasurer 2, and for the president 1. So the answer is also 6 ways. Okay, but of course, if we're choosing or if we have an election for positions, we usually call for the presidents first, right? So that's why I included the event wherein the president will be chosen first. Now, how about this example? A discount paint manufacturer plans to make several different paints. So the categories include the color, the type, the texture, and the use. So for this event, we have four: choosing the color, choosing the type, and here choosing the texture. Okay, and then we have the use. Okay, so how many choices do we have for the color? We have 1, 2, 3, 4, 5, 6, and 7. So this is 7. Okay, and then for the type, we only have two, 1 and 2. That is latex and oil. Then we have the texture. We have flat, semi-gloss, and high gloss. So that's 3. And for the use, outdoor and indoor, that's 2. So multiplying these numbers, that's 7 times 2 times 3 times 2. The answer would be 84. So there are 84 ways, or we have actually 84 options. These are the different combinations wherein you could choose a particular type of paint for your house. Okay. So for this next example, we have the digits 0, 1, 2, 3, and 4 are to be used in a 4-digit ID card. All right, so there is an identification card, and usually these identification cards have um, number on it, right? Like for identifying the employees or the students through numbers. So here we only need to choose from 0 to 4. Okay, and it's a 4-digit ID card. So the first is choosing the first digit, second digit, third digit, and then the fourth digit. So this is how we show the solution for this one. Okay, so how many different cards are possible if the repetitions are not permitted? Okay, so for example, for the first digit, we have 5 options, right? We have 1, 2, 3, 4, and 5. So these are the 5 digits. So I'm not going to write 4 here because I just saw 4 there. No, you need to count the number of choices that you have. Okay, so 1, 2, 3, 4, 5. That's 5 here. All right, so remember, um, repetitions are not permitted. So for example, in the first code you chose 2, then for the second code you can no longer use 2. I mean choose 2. Okay, so the options that we only have are 0, what else? 1, 3, and 4, right? So how many are they? They are 4. So after choosing the first one, the first digit here, we only have 4 choices for the second digit. Now after choosing the first two, then we only have 3 options here, and then only have 2 here. So it's just subtracting 1 for each event, right? So multiplying this, we have 5 times 4 times 3 times 2. The answer here is 120 ways. So there are 120 ways for you to rearrange the ID card by just using 0, 1, 2, 3, and 4 for the digits. Okay. Now, what if we have the same example, but this time we need to identify the number of different cards that we could arrange or we could have if repetitions are permitted. So there are times that repetitions are permitted. So for example, we have here the first digit, then we have digit 2, digit 3, and digit 4. So when we say repetitions are permitted, the ID number could be 333, right? Because a while ago in the previous example, repetitions are not permitted. So if you chose 3 here, you can only choose 0, 1, 2, or 4 in the remaining um, digits or numbers. Okay, so here repetitions are allowed. So after choosing the first digit here, okay, we still have 5 options again here because repetitions are permitted. So 5, then 5 here, and then still have 5 choices in the third digit and 5 choices in the fourth digit. So by multiplying this is 5 times 5 times 5, okay, or this is just equal to 5 raised to 4. You have your calculators with you. You can type 5 raised to 4, and then the answer is 625. Or if you could manually multiply 5 times 5 times 5 times 5, That's good. So we have 625 ways to rearrange those. Okay, so if you're the owner of the company and then you're trying to figure out the number of employees that you can have with different identification cards. So the maximum in the first one is 120, while if repetitions will be permitted, you will have several options, like 625. That's the maximum that you can have. Okay. Now, how about for this example? How many ways can 5 paintings be lined up on a wall? Okay, so here, is repetition needed? No, because if you posted the first painting here, say painting one, you can no longer choose this painting in the second, I mean part of the wall, right? The next part of the wall. So you can no longer choose the other one here. So repetitions here cannot be allowed. So sometimes we need to base our decision for the solution um, for based from the problem that we have. Okay, so we have the first painting here. Then how many paintings do we have? All right, so 5 paintings. So of course we need to put all those 5 paintings on the wall. So I have 5 events here. So 1, 2, 3, then 4, and then 5. Okay, so how many choices do we have for the first area or the first part? We have 5, right? But if say painting one will be placed on this first location, then we only have 4 in the next, 3 here, and then 2, and then 1 option here. Okay, so it's like subtracting 1 for each of this event. So multiply this one, 5 times 4 times 3 times 2 times 1. So this is similar to the previous example, and this is equal to 120 ways. So we have 120 ways to arrange this. For this next example, a car model comes with the following choices. So say you went to a casa and you'd like to choose a car for yourself, of course. 5 colors, with or without leather seats. These are the options that we have. With or without sunroof, with or without automatic transmission, then with or without a spoiler, and with or without anti-lock brakes. So in how many ways can the car be ordered? So we have several events here. So the first is for us to choose the color. So let's just code it as C. And then, so done with this. How about the type of leather seats that you'll have? So let's have with or without. Okay. And then without sunroof. Okay. So for the sunroof, say R. Okay. And then for the transmission, so we have T. And then the choice for the spoiler, that's S. And then the anti-lock brakes, which is P. Okay. Is that all? Yeah, that's all. So here we need to identify the options that we have per event. So for the number of colors, we have 5. And then for the leather seat, it's just with or without, so just 2. And then for the sunroof, same, with or without, so that's just 2. For the transmission, it's just automatic or manual, so that's 2. And then for the spoiler, with or without, so that's another 2. And then I guess you see the pattern here, right? So it's just with or without anti-lock brakes, it's only 2. So multiplying these numbers, okay, will give us 160 ways. Okay, so there are 160 ways for us to order the car. Now here, there are 7 athletes in a race. So how many ways can they finish first, second, and third? Okay, so the first event is for the athlete winning first, and then of course second, and then third. Now we need to think if there is a repetition here. Of course, if say person A will have the first place, he or she is no longer the choice for the second and third, correct? Because he cannot win first, second, and third simultaneously. So we can have here 7 in the first option. For the first, we have 7 athletes, right? But for the second place, if say person C will have the first place here, then he or she is no longer the choice for the second. So 7 minus 1, that's 6. And then 6 minus 1, that's 5. Because for the third place, we already have chosen 2 persons. So we only have 5 left. here. So multiplying these values, 7 times 6 times 5 will have 210 ways. So there are 210 ways for us to arrange the winners for the race. How many different 4-digit alarm codes can be formed for a house alarm? Okay, so we need to set a password for the house alarm. Now, the first digit must be 2, 4, or 9. And all the other digits can be any number, and numbers can be repeated. So we have 4-digit code alarm. So say code 1, code 2, code 3, and then the fourth one. Okay, so for the first digit, we have to follow this. Okay, because it says here must be 2, 4, or 9. So for the first digit, we only have three options, which are 2, 4, and 9. So three here. Now for the remaining, remember, all the other digits can be any number. Okay, and the numbers can be repeated. How many digits do we have? We have 10 digits, right? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So how many? These are 10 digits. And of course, if you're entering a code, it's just per digit. So we will not use 100 numbers or 1000 numbers, just the digits. So we have 10 digits. So we can select 10 here, then 10 for the third code, and 10 for the fourth, because remember, repetitions here are allowed. It specifically mentioned here. Okay. Okay, so the next is to just multiply this. We have 3 times 10 times 10. So that is what? 3000 ways. How many 5-character license plates can be made if the first characters are letters and last two characters are numbers? So repetitions of characters is allowed, but the first letter must be one of these given letters. Okay, so it's a 5-character license plate. So we have, say, letter 1, then letter 2, letter 3, and then number for the two remaining, right? Two characters. So we have number 1 and then number 2. All right, remember, the first letter must be just this choices. So we have 1, 2, 3, 4, 5, 6. We have six choices for the first one. And for the remaining, repetitions are allowed, or repetitions of characters are allowed. So we can choose A, okay, for the first three letters. So how many letters do we have in an English alphabet? We have 26. So this is 26. So I know we have different versions of alphabets, but let's just stick to the English alphabet. So we have 26 there. Okay, and then for the third one, since repetitions are allowed, I won't write 25 here, okay? Because repetitions are allowed. So let's just have 26 here again, okay? Now for the numbers, remember it could be any number, but since it's a plate number, digits are just our options here. Okay, so we have 10 digits, right? So 10 here, okay, and another 10 here. And all we have to do now is to multiply this for us to have 405,600 ways. And remember, these are the number of cars where we can put identical plate numbers. Okay, so that's how many cars can we assign different plate numbers. And that's all for this video. Now, for you to learn different kinds of techniques, you can just check all the videos available in the description down below. You can actually have the lesson for the factorial notation, wherein you could have a shortcut using your calculator if you have um, problems that involve these kinds of examples. See you in the next video.